Good morning. It's morning in California.
Yeah, it's morning in
California.
I'm
usually not up till about now.
So this is morning to you, Adam, essentially.
Good morning, Adam.
I felt so loved during the quarantine with all the people that checked up on me. Yes, it is.
I ain't got any good phone number.
To me,
Family and friends.
the most expeditious way of doing this problem here is to go ahead and solve by graphing.
That's what I did.
So if you set one side of the equation equal to 0, you're going to have this. So we go to our calculator and we get this thing here, right?
Yeah.
And then I'm just checking to make sure you're okay. Go like this. So you get, when you graph, you got something like this, right?
Yes.
And then second trace, 0, and left bound, enter, go to the right of the 0, press enter twice. So your answer should be negative 2/3. Now I'm seeing a few of your answers come down as 2/3 and not negative 2/3. How did that happen?
Probably just forgot.
Yeah, I don't think I saw that. I just forgot.
Forgot to put a negative sign there? Okay, because what it is, so if I don't see much work done, I'm assuming probably it was done by graphing, right? Because you can graph this thing in your calculator without writing anything down, right? You can just take it directly from your paper and put it in your calculator like this. And so, did anybody work it out? Did anybody work out the long way by clearing out the denominator? You did? You got the same thing? So you and Karina today are my overachievers on that, so good job. No, that's good, but it's corroborative, and you also got an extraneous solution, right?
Extraneous.
Yeah. So you're not going to be tested on that on Wednesday, by the way, on that word. But you remember extraneous solutions, right? That was back before the break. You don't remember? We started solving. Right? That was section 2.7. So it's been a while ago. All right, so next, this one right here, basically you have f of g of x. So what you're going to do is you're going to place this g right into x here.
Yes.
So f of g of x is equal to, you take this 3x plus 1 squared, and then plus x, in place of x you put 3x plus 1. And finally, we have this minus 6 over here. So you square this out, you get 9x squared plus 6x plus 1. And then you have right here this, you have plus 3x plus 1 minus 6, so you get 9x squared plus 9x, and then you have minus 4. Is that what remember you look like there? Is that what you got? Okay, good work.
We got 3x. Oh, we did it.
You did it backwards.
Yeah, so make sure you check your work on this thing, right?
Can we get our paper back?
No, you'll get a grade on it, but it's a class grade, right?
Okay.
You guys, most of you have like 105.
Yeah, we understand what we did wrong. We forgot to square the 3. We just had 3x squared.
But that's part of the reason we're doing this, right? To
Yeah,
sort of
makes
get you right for x. So now we have inverses of each other, f of x and g of x. So to find this, if we go through the process, and then we go ahead and switch x and y, and then we add 2, So here's the replace f of x with y, here's the switch x and y, and here's the solve for y. So then we divide by 3, we get y equals x over 3 plus 2/3. And that's going to be g of x too, right? So g of 4 is equal to 4 over 3 plus 2 over 3, which is 6 over 3, which is 2. So 2 is going to be your answer for this one. I saw some people got a little bit different answer.
Yeah, we got that. I don't know if I got that. I think we got it.
But anyway, so that's how you do
No, I
it,
think we got it.
right? So a lot of people, probably most of you got. So that's that. Now, today with the remainder of class, we're going to be talking about these kinds of problems right where here. We're going to talk about compounding interest problems. And the other day, I gave you the ACP formula chart that has these on there. I'm trying to find my, where is my stuff? There's that, there's that. Oh, here it is. I know I have it here.
No.
One back.
You wanna know what it is? No, it's not. But I already have. Well, I like it. Yeah, I think it might have a thing. May not, I don't know. No, can you give me another food? No, you're gonna make it die.
And he's a friend, you
No,
know?
that would kill it.
You're a regular friend.
Beta fish or territorial?
Yeah, he's a regular friend. Yeah, regular, no, you're regular. Hey, fancy shoes,
Hey,
dirty shoes.
Okay.
you let your dog sit on those or something?
Yeah.
Okay, so I've handed out the compounding interest problems sheet, and we probably aren't going to go over all these today, so we'll probably finish this tomorrow. We'll sort of just get started on this today. Basically, on the sheet itself, they have this they're compounding interest problems, but I also have added this continuous compounding formula to it, because we're going to compare and contrast periodic compounding versus continuous compounding. And where do those formulas come from?
The sheet
Exponential
you gave us.
Yes, okay, thank you, Will, yes. Basically, we're talking about these two formulas right here. The compounding interest formula and this one right here. Now, as it turns out, the continuous compounding is becoming more and more relevant today than it was 20, 30 years ago. Why do you think so? Why do you think?
Computers.
Yeah,
We
computers.
have so many more new things in the world. So much more technology.
Yeah, and so what it does, it makes the calculations a lot easier, is what it amounts to. And so really, the periodic compounding is not done nearly as much today. When I had my savings account when I was a little kid, they would do quarterly compounding, and they would have this, you get this savings book account, and every quarter they would put down, every calendar quarter they'd put how much your account was worth. So, anyway, here we are. So what I want you to do for these problems is to do it two ways. Do one as instructed, as with the periodic compounding, and then also do continuous compounding. So here we have Heather receiving $100 for her 13th birthday, and that formula is going to be A equals A sub 0, and then we have 1 plus R and it's going to be the power of t. Now, this formula looks exactly like the ones we did before, right? But with compounding, how do you change that? Well, what you do is you take your interest rate and divide that by n, and to compensate for this division here, you multiply the exponent by that same value, n. And now you have to figure out what is n in this problem.
N equals,
What is n in this problem?
3%.
No, r is actually 3%.
0.25.
Okay. Okay, you look at the word quarterly, right? So quarterly, the answer to the question is how many times does quarterly occur during a calendar year?
4.
4 times. So the answer to this question, what is quarterly, is 4. So you have to look for that. And of course, weekly would be 52, daily would be 365, yes, very good. So now, we're going to go ahead and do this. So in this case, we're going to have A is equal to 100 times 1 plus, and what is R?
3%.
And really you need to write this in decimalized version, to the power of 12, which is, I'll put 3 times 4, but Will's right. And then you work this out and you get your answer, and in your calculator,
109.38.
Ooh, a whole $9.
yeah, so we get, I'm going to put this 100 times 1 plus, we put this 0.03 over 4, and then like Will said, it ends up being the power of 12, and you get this as your answer. So 109.38. So this is quarterly compounding. Now, continuous compounding is the equation P, it's A equals P times E to the RT.
That's a good rhyme.
Yeah, it does, it kind of rhymes that way, but that's in your formula chart, right? So you can see it right there. So anyway, here we have A is again equal to 100, and that's going to be E, and RT, that's going to be 0.03 times 3 for T. And then we're going to get our answer for that.
They're going to be the same?
Actually, let's do that. We'll answer the question after you do it. That's a very good question. And that's part of the reason I'm doing this today too, like I am. So here we have 109.42. So we'll say 109.42, round to the nearest penny. So this is continuously.
That just sounds off.
So continuous compounding versus quarterly, and what you're going to be able to do throughout this exercise today is kind of compare and contrast, and you'll see that you're going to have, now if you compound a lot, like if you compound very frequently, like weekly or daily, continuous isn't going to give you hardly anything more. Okay?
I got a question.
Yes.
So is monthly going to be 12?
Okay, is n for monthly going to be 12? Yes, it is. Now, if it's only if it says annual, if it's annually, if it's interest, they're usually talking about annual interest, so then n would be 12. So go ahead and do number 2, and we'll just kind of leave it at there today. So just do number 2, and we could just leave it probably right there
Yeah,
today.
I don't know if we'll finish
Yeah, to you will. Okay, it's the same thing as number 1, but you put .04 instead of, in place of R, and you put 12 in place of N. Otherwise, and then 1,500 for your principal. Everything else is the same. And also in this one here, we're talking about 1 year. So what is T going to be? 1, as in 1 year.
Wouldn't it be 2? Because it's last summer's deposit.
If he deposited money for his compounded monthly here last summer, how much is going to have next summer? And it doesn't say, you have to make some interpretations a little bit, right? And the way I would interpret this was that it's a year later. So how much money is he going to have, a year later? That would be my interpretation. But you're right, there is some ambiguity there. So we have to make an assumption of a year, probably. So let's just, what did you get for quarterly on this one?
1,561.11.
60.11?
Isn't it monthly?
Is that for monthly?
Yeah.
Yeah, okay. That's monthly.
Yeah, that's monthly, my bad.
That's what the question says.
Now, what about continuously? Did you figure out that way too?
1,561 and 21 cents.
1,561, and how much?
21.
21 cents?
Yeah.
Okay, this is continuous. And again, the formulas for that are going to be, for this one, 1,500. A equals 1,500 times e to the .04 times t, which is 1, right? And this one here is going to be a is equal to 1,500. 1 plus .04 over 12 times 12t, which is that. So that's how, those are the equations you'd use, right?
Yeah, it's a 6.
Okay,
What's
yes.
the continuous be 2 too, since it's a 6 and you round it up?
Is it rounded the wrong, they didn't round it enough? Angel, are you supposed to round that to 22 cents, Angel?
Oh,
He owes
yeah.
you a penny.
Yeah.
Okay, Angel's being the bank, he's trying to shortchange us a little bit. That's okay. So we will just leave it there today. Thank you for your participation, good class.